Good afternoon, ladies and gentlemen, and thank you very much for attending this particular session. What I'm going to talk to you about today is what we do at Quickstep. As you've heard in the introduction, we have been involved in composite material for quite some time and large project on the other, and we'll show you what we've done and what we're planning to do on this particular company. Just a short slide to sort of express a bit what we do. Quickstep, the composite revolution, we work in composite material. Our positioning is we create carbon composite solutions, basically. As you know, carbon fiber composite is 50% lighter than steel and about 30% lighter than aluminium. So it's a very strong, very light material, and we're very much in that space. We have two main activities, licensing of composite production technologies on one side, and manufacturing of actual parts in the composite aerospace as well as automotive. We own and we have patents on a disruptive technology which is patented and validated, which is called the RST, which is resin spray transfer, which represents best value for money on the market at the present time. And that's on the technology side. On the manufacturing side, we have a base of activity with very high visibility, mainly in the military sector. We have secured about $800 million worth of contracts over the next 20 years, mainly on the GSF and C-130, as we'll see in the next few minutes. And we have a very high growth potential activity beyond that particular thing in terms of the high-end automotive industry and the civil aviation as well, using our own technology. So exponential growth. The revenue in 2012-13 has been about $5.7 million compared to $500,000 the year before. The revenue for 13-14 is going to be around the $18 million, and the year after is going to be around the $37 million. So a very, very quick growth in terms of the revenue. And we'll be profitable next financial year. We'll be cash flow positive next financial year. We've just finalized a capital raise just in the last 6 weeks or so. We raised $12.7 million at that time, and that money will take us to cash flow positive. So we've de-risked the company quite substantially in the last few weeks, and we still have all the upside of a very innovative technology and a very good manufacturing business. So let's go into a bit more detail in here. Our head office is in Sydney on Bankstown Airport. We have about 95 employees there. That's our headquarters and where we manufacture. We have two subsidiaries. The problem we have is that 100% of our turnover is made overseas. We don't sell very much in Australia. So our markets are typically in Europe and in the US. We have a subsidiary on each side. Both of these subsidiaries are very close to markets that we have interest in. Munich in Germany, where we're physically located in the premises of EADS, Airbus, and also Munich, as you know, is a capital of the car industry as well. We in the US, we're present in Dayton, in Ohio, which is where the research labs of the Air Force are located, but it's also 2 hours from Detroit, and a major area in terms of automotive industry. So we're present where our markets are, which when you operate out of Australia is really very important. So our business model, two things as I mentioned before. We license our own technology, and that's how we make money by supplying the plants themselves and then collecting a royalty on the sort of products that are being produced with our plants. On the other side, we derive revenue from contract manufacturings to make complex carbon fiber parts, mainly for the aerospace and defense industries. Why the defense industry? Because they're very high barriers to entry. It's very difficult to get in, but when you're in, you're there for the very long term. And second, we have no serious competition in Australia. Really, Boeing is the only one that does serious work in there, and they only work for themselves for Boeing commercial. We're basically open to anyone that wants carbon fiber parts made in the aerospace industry. Two major contracts, and we'll go into a bit more detail a bit later. One is on the F-35, the new fifth-generation fighter that we started in Perth in 2012, and that we've continued in Bankstown, our new location. But also another contract doing the C-130J flaps for Lockheed Martin that we commenced last year. And we're bidding for a number of very significant projects in the same way. So model, two things, our patents, licensing, on the other side, manufacturing. If you look at the forecast demand for carbon fiber, it's actually growing extremely fast. You can see in grey the growth for the use of carbon fiber for the aerospace industry. As you can see, it's significant already now, but it's going extremely fast afterwards. If you look at in red, it's the same for the automotive industry. You can see that we started even smaller, but as you go in 2020, the quantities have risen, even further, even faster. So that's the two areas where we are focusing our attention. In blue, you have the more industrial and consumer products, which is not the focus of the organization. It's different technologies and different qualities. Here we're talking about very high quality products that we're talking about. So that's where we focus on those two markets. So what's the principle of our technology? It's actually quite simple. The way you actually cure a particular part, carbon fiber composite part, is normally cured in temperature and under pressure in a system that is called an autoclave, which is a high pressure, high temperature sort of an oven. They're very expensive to maintain. They're very expensive to invest into. They're driving costs all over the place. What we do is use a fluid to do that transfer of the heat. So our system is actually using a high temperature fluid that comes into contact with the part. So you have in green the tool that gives the shape to the part. In red you have the part itself. And you can see that then it's immersed into a clamshell sort of an organization whereby you circulate a fluid underneath and on top of the part, separated from the part by a flexible bladder so that you don't contaminate the part as such. And then you circulate that fluid and you actually heat that part much faster than a gas, which is typically what you use inside an autoclave. So what are the benefits for that? Much faster on one side, much cheaper because the equipment is a lot cheaper to A, buy, B, maintain. And you manage to get very high quality parts using that. So what's our competitive advantage in the automotive industry? We'll start with the automotive industry and then we'll go more into aerospace and into the manufacturing. Well, as you probably know, there is a move to carbon fiber composite linked to legislation in Europe. At the present time, the CO2 emissions are much too high for the car industry, and the legislation in Europe has mandated a very steep reduction into CO2 emissions. In next year, we'll be at 130 grams per kilometer, which will go down to about 95 grams in 2020 and even lower afterwards. Typically, a small car today in Australia, sort of a Barina, would make 150 grams per kilometer of CO2 per kilometer. The tax is 100 euros per gram. So at the sale of the car, you'll pay 100 euros per gram. So if you're at 150 grams, like our Barina we just took as an example, you'd pay 2,000 euros of tax at the time you sell the car, the new car. Obviously, for a car that is worth about 10,000, it's prohibitive. So that has pushed considerably the CO2 emission reduction into the European market. The US have a similar scheme, which is a bit later in terms of acceptance, but a lot of the South American and a lot of other countries have gone into exactly the same scheme. It seems that Australia is the only one that doesn't have that. So at the end of the day, if you have carbon fiber that reduces your weight by half, your consumption is going to be reduced by about half as well, and your CO2 emission will be reduced accordingly. So all the OEMs in the car industry have an interest in carbon fiber, which is going to resolve a lot of their problems. We're not the only solution to the problems, but it's a huge area which is being explored as we speak. What you need to be able to do a part that way, what is the holy grail of carbon fiber parts? Well, you need three things at the same time. You need to be low cost, you need to be very high speed. People in the car industry, they don't joke. If it takes you 12 hours to do a part like we do in aerospace, it's just too long. I mean, it's the cycle and the number of cars that are being made all the time. They say, above half an hour, we're not interested. And the real target to make a part from A to Z is probably about 5 minutes, not 8 or 12 hours like we do in aerospace. And you need a quality finish as well. If you talk about external panels, the quality of your external panels have to be, really, really nice. Otherwise, you simply won't sell a car. And not very many technologies actually can deliver this. The problem is lots of people can do 2 out of these 3. It's reasonably simple to do 2. But to do the 3 is, not very many people can do it. And we're one of the few that are in that particular position. So the principle is quite simple. We actually spray a resin on top of the mold. We put some dry fiber on top, and then we cure the whole thing, using Quickstep as our fluid, as we described before. So it's a very, very quick operation. In a few minutes, it's actually all done, and it gives you a part that is ready to be painted right out of the mold. Again, quite a disruptive technology that works very well. So where are we in terms of that success? The technical success has been confirmed. We've demonstrated a part that has been approved by a European luxury car maker. So it's not as if we're trying to sort of see where we are. We've gone through very exacting tests in terms of cycle in temperature, in humidity, that demonstrates that the whole thing actually gives you the quality that you need. And that's done by one of the top luxury car makers in Europe. We have an experimental production line that has been commissioned. You can see in the photo here in Sydney that is operational now. So we can do small quantities right now. We're operational right now. Further developments are underway. We're working with Audi and Lamborghini on this. To be able to do much larger quantities. At the present time, we've already shown that we can do smaller quantities in a competitive way. The sort of work we do with Audi, for instance, is to reach about 75,000 cars a year. So from a few thousand, you go to 75,000 cars, which is a lot more. So we have given a few quotes already to a number of car manufacturers, and they've shown a lot of interest. The sort of costs that we've quoted are very much in the sort of budget that they've got. Most of that has been, most of the research on this particular technology has been funded by a climate-ready grant from the Australian Oz industry here in Australia. And as you can see on the bottom picture, the plant itself was inaugurated by Kim Carr in August of this year. So, and you can see the sort of part that he's holding here. Very hard to see the quality, but I can tell you it's a Lamborghini part, which actually looks extremely, extremely good. And if Lamborghini accepts it, that means there's something right. Just to give you an example of where we are in terms of competitiveness, at the end of the day, that's the name of the game. You have in red the price of the part in aluminium. Here on the X-axis, you have the number of cars per year, and for that typical part, in the Y-axis, you've got the price of a part. So you can see that aluminium is in red, RST, our technology, is in blue, and steel is in green. So you can see that this is actually done in terms of a price comparison at today's carbon prices that are quite high. And you can see that we're basically already pretty much competitive against aluminium up to about the 50,000 cars a year. And steel, well, of course, steel is quite cheap. But if you reduce the price of carbon by about half, which is really something very realistic in the next 5 years or so, you can see that we beat aluminium every single time, and steel, which is twice as heavy, by the way, and has other problems in terms of taxes, as we described before, we beat them up to about 10 or 12,000 cars a year. So you can see that there is this technology is already competitive, which is why there is so much interest from those manufacturers in Europe. So how do we make money out of that? Well, it's quite simple. We would do the plant itself. You can see the plant here, which is this tray and the robot here. So we would sell this, and each of them is worth about $1 or $2 million each. For us, in terms of turnover, if you want to equip a full line of about 20,000 cars a year, you need about 12 of these machines, and that's about 20 million turnover for us. So it's a very, very lucrative already from the start. We would do, in addition, we would get some royalties out of the patents that we have in place for this. And we would start as well to do our own production for smaller quantities. We need to be able to continue developing the technology as we go. And unless you have that capability to do smaller quantities, it's very hard to sort of keep ahead of the people that are going to use your technology. So, that's how we're about to make our money on this. We have the key patents are in place until at least 2022, and we evergreen them all the time, so we sort of improve all the time, and so we keep our patents current. And of course, we are protected through the know-how and the sort of other aspects of this technology. Okay, so that's for the technology. If we now talk about the manufacturing, we have a brand new plant that we've inaugurated in June 2012 in Bankstown Airport. We've invested about $16 million into that plant, which is a fair bit of money, and we're the largest independent producer of aerospace-grade composite in Australia. So let's say Boeing is bigger, but they're not independent for sure. So our first part was delivered from Bankstown in February of this year. More than 100 parts have been delivered to date. Remember that each of these parts are worth between $20,000 to $50,000. So that's they're quite expensive to start with. We have capacity to serve large-scale, long-term contracts, and we can actually increase our plant because the footprint we have at the present time on the Boeing ex-Boeing plant that we occupy is about a third of what Boeing is about to vacate in the next few weeks. We've divested from a plant that we had in WA before. WA was not exactly the best place to do aerospace parts, and so we've decided to come to the East Coast, which was a lot more adequate in terms of support and staff. And a lot of this facility has been funded as well with some support from the government, New South Wales government, but also the federal government. So we have a lot of support from them. You can see that this picture is not because I'm on it. It's because on the left side you have the president of Northrop Grumman Aerospace System Division. This guy has got about 10,000 people working for him, and he actually went and came to cut the ribbon at our place last year. Northrop Grumman is our biggest client, but to send their president like this was certainly a very positive sign that they appreciate what we do. The other guy you all know is Barry O'Farrell, and Premier of New South Wales, so we have that support as well at that level, and same as I said on the federal level. So we have lots of people that like us and really consider that we're doing a good job. So what are we involved in? Joint Strike Fighter Agreement. You're probably aware that the Joint Strike Fighter is the largest defense contract in the world, about $300 billion. Even for our 100 that Australia wants to buy, it's our biggest program at the present time in Australia. 3,000 aircraft to be purchased over the life of the program. About 60 have already been delivered. So we are at the very beginning of the program really now. As we go, this program will be the third biggest program in terms of numbers of aircraft per year, behind the 737 and the 320. So if you want to be involved in a very large quantity manufacturing, well, military can be very good. This program is third biggest after the two best sellers on the commercial side. What have we done into this? Well, we've continually delivered the first milestones that we had to pass to sort of get into it from the moment we signed our first MOU in 2009 until we started to produce real parts that have been delivered on time. We have in excess of $7 million of firm orders onto this, but we have several long-term agreements for a lot more than that. and we expect revenues of about $40 million per annum by 2017, 2018, when the program will be at maximum rate. Remember, we do parts not for Australia only, we do parts for the whole of the supply chain, for all of the aircraft worldwide. The agreements that we have are valued at about $700 million over 20 years, so it's a very substantial program, and very prestigious. The other contract we have is the C-130 flaps, and you can see these things at the back of the wing. You've got 4 of them. We've been selected to manufacture those wing flaps in March 2012. That was won against global competition. JSF was, a directed program, but we had to meet budget, so it was not exactly easy. This one was completely an open competition. We won it against 3 American companies and 1 South African one, and we came on top. So the preliminary work is underway. We have a contract for $1.6 million to do it. We have received our first $12 million contract for the first production order, which is 24 ship sets to be delivered from the end of this year till the end of next year. So on the calendar, basically 2014. Because the first parts are to be delivered in the next couple of months or so. So we're very much on track with that, and it's looking like a very interesting contract. The overall agreement is valued at $75 to $100 million a year, altogether over 5 years. So it's another very significant contract for us. Another contract that we've signed very recently, in July, is for a Quickstep machine to work in to do parts for the space industry. So it was interesting to see the previous speaker about that. So that machine is to do a part that you can see on when you have a launcher that actually launches a satellite. The payload is on top, and you have 2 fairings that basically protect the satellite during the first few minutes of the flight when it crosses the atmosphere, but it also gives it a aerodynamic shape. So that company in Russia actually was interested by our technology. They bought our machine. So that's the machine. That's a perspective of the machine that we are about to deliver to them. The contract is valued at about $6 million that will be delivered in the next 18 months. For us, it validates our technology. It's the first machine that we sell not to a university or a research institute. It's going to do real parts, with applications in the space industry. It's of particular interest for us because it will allow us to do very large parts, and that's an area that we expand very quickly into. We have lots of talks with people like Boeing or Airbus at the present time to do full wing skins in carbon with integrated stiffeners. The size of these wings would be about the size of the part that we're talking about here. The machine would be the same. So it's part of a stepped approach into technologies like the one I just mentioned, stiffened technologies for very large part in the aerospace industry. Growth opportunities. As I mentioned before, we have a very positive reputation for performance for JSF, and this is a very small industry. If you don't perform, you're in trouble. If you do perform, lots of people are coming your way, and so we have we're very well known. The number of very major primes in this industry is small, and they all heard about us, and so we have a lot of commercial activity to try and get further contracts, and we have a number of bids that have been submitted and that are being negotiated as we speak. That focus that we have in the manufacturing itself is mainly military, because that protects us against the low labor cost countries. At this stage, Australia is a first world country, and we have costs that are going accordingly. We have staff that are highly competent, and if you get them menial tasks to do, well, the Chinese can do it much better than we can. So we focus on very high value added and where people can afford to pay very sophisticated parts at a higher price. That's why military for us works very well. In terms of addressing the commercial market, we still do. But by selling the technology rather than selling parts themselves. So, in conclusion, we have in excess of $30 million of firm orders in hand, which is backing the next 18 months of turnover. We, as I mentioned before, we've done about $5 million revenue this last year. We'll be at 17, 18 this year, and at 30, 35 the following year. So we have the orders to sort of reach that. So it's not a question of if we can do it, if the contracts are let. We have them now. The future sales on JSF are supported by a $700 million memorandum of understanding, which has been signed with Northrop Grumman and BAE. We have capacity in that new factory to do about $100 million worth of work without substantial investment. So only 60% of that would be utilized when we're at peak on the two programs, JSF and C-130. As I mentioned, 40 million for JSF, about 15 for the C-130, so that's about 55. So there's plenty of more capacity, and that's why we're very active at the present time on the market to sort of fill it up as fast as we can. So that's on the manufacturing side. On the technology side, we have a very good technology, very disruptive technology for the automotive market that has been recognized by leading European OEMs, which is very attractive and is getting a lot of attention worldwide. We benefit as much as we can from the different incentives in terms of R&D in this country and elsewhere as well. As I mentioned before, we've just raised $12.7 million in the last 6 weeks or so. That particular capital raise is taking us from where we are today until we are cash flow positive, so we don't need further raise of capital to get there. That is de-risking considerably the organization, and of course, get us to fully realize the potential of the organization through the further manufacturing and further use of our technology. And we're targeting to be cash flow positive from next financial year. So certainly a very good company to invest in. I'm sure you'll agree. That's all I had to say. Thank you very much for your attention. And is there any questions?
Thank you very much. I wonder if you could comment on the history of the technology, where the patents are registered, and what your focus is for R&D in terms of rolling out the technology further.
The patents we have are, well, it depends. We have about 6 or 7 main patents. They are registered in most of the developed countries. Basically, we don't cover necessarily every single country in the world. It's a bit expensive to be on that gravy train. But any country that is likely to ever use the technology is in there. So the US, any European countries, China, and a few others. So that means that even if a small country starts manufacturing using our technology and breaching a patent, the moment they sell it, they're being caught. So yes, so in that sense we are well protected. But remember, a patent is fine. The know-how is even better, and this technology is not very simple. There's a lot of know-how that comes into it that protects what we do. In terms of further development that we're looking at. In the auto industry, I've mentioned that one of the purpose of what we're trying to do is accelerate, make sure that we have a product that is much faster to make. At the present time, we are at about 30 minutes to do a part, which is a bit long, but it works today, as I mentioned. That's something that we can produce today. So we have a number of programs that reduces that time to about 5 minutes. So that's further R&D that we're progressing in the next couple of years. One very interesting aspect, to be slightly more technical, is what we call sandwich parts. The present technologies are not very good to do sandwich. As you know, if you do sandwich, you have a layer of carbon, a sandwich, a core, which used to be balsa in the good old days. Now is typically foam, and you put another layer of carbon on top. So all the technologies that exist today have got great difficulties to do that. The fact that we're spraying rather than injecting under very high pressure makes it very easy for this particular aspect to work. So we do a lot of further research into this, which we believe is a discriminator in terms of technology. So that's mainly on what we work on. Faster curing cyclones, not only the resin but the machine as well. And on the aerospace side, a lot of the work that we do is in research that we do to introduce the technology into the GSF at the present time. So we're working with the support of the US and Australian government to qualify SPAs in particular, to be introduced into the scope of work that we already have on GSF, and that would use Quickstep rather than traditional technologies. So that has shown a lot of interest from the US government, from the GSF project office in the US government, as well as Lockheed and BAE Systems, the contractors at that level. So that's another axis which will then lead us to making SPAs for commercial as well as other military aircraft. The other aspect of what we develop at the present time is very linked to, as I mentioned before, skins with integrated stiffeners, all done in one shot for very large parts. I mentioned skins for wings in particular, but there might be plenty of other applications in that industry. Our technology again is very disruptive in that sense, and it's actually quite. We have a lot of interest from Airbus in particular in that area. We made some business cases with them on a door skin. The cost of that door was half the cost of traditional technologies. So you can see the sort of interest that people can have in that sort of order of magnitude.
Philippe, regarding the long-term agreements, it seems you've signed 2 to date as of June 2012. I'm just wondering, when is the next long-term agreement, and how much do you expect it will be for? I think to date you've got about $30–40 million worth.
Yes, we on the GSF we have 3 groups of parts, and as you mentioned there, we have signed 2 long-term agreements, which are typically for 10 years. The third one is actually has already been negotiated, and it's about to be signed. There was one particular item we needed to close with Northrop Grumman before this would happen. It's likely to be in the order of about $150 million worth of contracts as we go in the next, probably before the end of the year. So remember that long-term agreements are define your terms and conditions and how the price and everything in the contract. It doesn't give you the quantities. The quantities are given on the purchase order on a yearly basis. So long-term agreements are great, and they give you that certainty over a long period of time. It doesn't give you the guarantee of the quantity yet. Well, that's how the whole of the U.S. industry, defense industry works. You've got trillions of dollars being spent that way every year. You have to sort of follow the same process here. But having a long-term agreement gives you another level of certainty that you probably don't have otherwise.
Does it make sense in the medium term for a company like Quickstep to be based in Australia? And secondly, have any of your larger competitors invested in Quickstep?
That's an interesting question, and that's a question I'm asking myself every time I step on an aircraft, which is very often. As I mentioned before, yes, all of our contracts are really overseas. In terms of manufacturing, it makes sense to be here. There's no doubt about that, because we have obligations to do some work against the military contracts that Australia signs. So in that sense, we wouldn't do the manufacturing elsewhere than in Australia. In terms of the patents and the rest of the activity, frankly, we could be located anywhere. That doesn't make much difference. The manufacturing gives us the bulk and the credibility. We need it, and before we actually started to engage with the big guys and start delivering the quality that we've been delivering, we had little credibility in the technology. The moment we started to deliver and deliver on time and do good quality, your clients are all over you saying, "Oh, how can you reduce your cost?" "Oh, guess what? We've got a technology. This is what you can do." And so the virtuous spiral, basically, when you start delivering even on a build-to-print basis, actually improves as you go, and the company gets larger. It gets more stable with contracts. It gets more stable financially, and then you start getting your customers saying, "Well, we want more of this, and we want more technology and lower costs." So, in that sense, being in Australia has some sense. The fact is that we're already a global organization. We are a small organization, but we're global. We're organized in that way. We do R&D, split across the world, and we don't do the same research twice. We share the results and make sure that at the end of the day we optimize the way we spend our dollar. What was your second question?
Let's go to the last question and then.
Just wondering whether any of your large competitors have invested in Quickstep yet.
No, our largest shareholder is Saul Pattinson in Sydney. We have mainly shareholders out of Australia. We've started to diversify that into Europe in the last capital raise that we did a few weeks ago. There's more and more interest shown by overseas investors to that technology. There's an interest not necessarily by competitors, but by people that are possibly in the value chain that we belong to. So either molders, people that are making parts using our technology possibly, or people that have interest in resins, for instance, because we actually modify that resin and cure it. So we have discussions, we have very close discussions that could lead somewhere possibly, who knows. Thank you.